Greetings to Dr. Lau and my fellow college mates. Today I'm about to present to you two software architectural styles, which is the service-oriented and public subscribe. So I'm going to start off by explaining what is service-oriented architecture. So if one asks two people to define SOA, one is likely to receive two very different and possibly conflicting answers. Some say that SOA is actually an IT infrastructure for business enabler, while others perceive that it's increasing the efficiency of IT. So basically, SOA can be defined as a loosely coupled architecture, design in which necessary components functions are created as reusable service. So now I'm going to give an analogy of how service-oriented works in reality, so you can visualize better about it. Okay, given that in town A, they provide transportation service to allow citizens to move from point A to point B. These services include bus, car, ferry, and by train. So what it does is every citizen who wishes to use these services, they need to register themselves into it. So in this case, bus actually stores the data of the citizen into the server, and ferry actually uses paperwork. So these citizens, to use these services, they actually have to go each of these services independently and to update themselves. So as time goes by, as the population increases, it gets a bit more complex and takes more work because each of them have to actually go these services independently and to update. It's kind of like, complex, all this kind of thing. So what SOA comes in place is actually to build a transit pass. What it does is this transit pass actually connects these services and then to allow each citizen to actually update themselves here. So for instance, you can update yourself. Maybe you change your name and then you wish to update yourself in all the services. So you just have to update yourself here, and then this transit pass actually pass on this data back to all the services. So from this concept, we can actually implement more services in this town and to allow the citizen to use different types of transportation to move around. So in other words, the concept of SOA is to basically to create functions for specific operations as reusable service to combine these services to build a particular system. So similarly, it works like a middleware that connects services, and yeah, that's about it. So the purpose, it's about fixing existing architecture by addressing most of the major systems as services and to abstract these services into a single domain and form a solution to it. So as we know, each of these services are independent and they speak different languages or perform different things. So SOA actually helps to build the bridge and to connect them. Therefore, the larger chunk being abstracted, the fewer interfaces are required to implement for any given functionality. So if a service presents a simple interface, this extracts the complexity away for the users. So this eventually helps and aids the users to access independent services without knowing any detailed knowledge of their implementations. And this means that same interface can offer by many implementations, and conversely, that implementation can change without affecting the aggregate applications. So there's a myth and fact about what SOA is all about. So saying that SOA is actually considered a new thing in this society, it's actually no. SOA is actually derived from and evolved from the concept of COBA, DCOM, EDI, DCE, etc. And SOA also uses the similar concept of public and subscribe architecture, where it actually consists of a middleman or a middleware to actually connect these services. And also they said that SOA required web services. It is not necessary that SOA have to implement there, but it can be realized through web services. So the strength of SOA. Since we already know that loosely coupling is one of the features of SOA, which means each of these services operates independently and functions its own operations. So which means, for example, okay, in this image, in this diagram, it actually shows an architecture of how SOA is like. This reusable service actually collects data from external data, marketing data, and finance data. So probably this service is to calculate the stock of the products, and probably this service actually manages the data of the customers. So what this composite application is to combine few of these services and to build an application for client to use. So this consider, how is it, the integration becomes more forethought rather than afterthought, since we knew that this service, each of these service actually can be written in different languages and platform, and this actually reduces the integration expenses for an organization to collaborate these services together to form a system. And SOA also functions in a runtime environment. Since we know that SOA helps to build bridges among services, we do not have to know the detailed knowledge and implementation like I just said before. So now developers can be more focused on building their own service or their functions for specific operations, since we don't have to know how to integrate the services together, because SOA helps us to take care of that. And reusability and extensibility is also one of it can be increased because it allows services to be reused. So it makes it unnecessary for organizations to start from scratch to if modification needed or any upgrades. So this eventually helps the organization to save cost and time. The next thing I'm going to talk about is the weaknesses of SOA. So the major weakness that can be found is actually the complexity of implementing SOA. Since we know a system can be encapsulated by many types of services, so each of these services, when they exchange messages to perform tasks, managing them can be really complex. For instance, you have like maybe more than 100, 200 services, and they exchange data maybe from MongoDB and from NoSQL database. So this can be really complex when they actually exchange a message to perform their operations. So now moving on to examples of SOA. Well, I actually found that cloud services actually implements SOA as an architecture. For instance, I chose IBM Bluemix. IBM Bluemix is actually a platform as a service, which means all various details such as the application server and authentication handler has been taken care of by the cloud, which means the client just have to care about how to build the application, how to actually use this data among these services, and to build software out of it. So it's actually building an application on the pre-built middleware, which is the IBM Bluemix, that does automatically all the things for you. So this is IBM Bluemix. So due to loosely coupled, they actually consist of various API and services that perform specific operations. As you see, this is actually an IBM Bluemix website that it shows you different types of services. For instance, the push notification by IBM, the MongoDB, the MySQL. All these services works independently. So IBM Bluemix helps provide these services for you to use. You just know how to use it, and it connects for you in the IBM Bluemix to integrate for you. Yeah. Next, I'm going to show you of how the user actually create a web page using IBM Bluemix. So what it does is actually the user code the application using .java, and the IBM actually provides some sort of services, which is the Watson Personality Insights, creates a cloud NoSQL database, and it collaborates these services for you. So this is actually the dashboard of the IBM Bluemix. So we can actually add the services, or we can create our own services to perform your own operations like what you want, and we can actually just bind them just like that. You don't have to integrate manually and to connect to one another. So this actually proves that IBM uses this software-oriented architecture because it helps us to connect these services, allows us to create a new services by ourselves as an independently, and also helps us to integrate. So the next example will be an IDE. For now, I will choose Node-RED as an example. Node-RED is actually a graphical IDE that uses SOA. So it consists of plugins and API called Node, as you see here. Each of the node provides some sort of functions. So what it does is actually you just have to drag a node, another node, and just connect them. So by doing that, you actually create some sort of system or service for yourself. So it's actually a loosely coupled concept where we can create our own node and we can just collaborate together. So this node can be written in different languages, and it helps us, and this Node-RED just helps us to integrate. So it is an example of how Node-RED looks like, where you drag and drop the nodes and then connect them, and then it, build an application for us. An example again. So you see, this is actually a MongoDB, and then you can actually use a function called Twitter that actually gets all the tweet and then saves us to MongoDB. So it helps us to integrate from like different platforms, just like that. So Node-RED allows to save useful functions, templates, or flows for use as a service, and Node can either be written in JavaScript or HTML. This similarly looks like the IBM Bluemix, where you just have to it actually helps you to connect these services and to build a system out of it. So the verdict, in my opinion, I think SOA allows developer to focus more on building the particular service, since this architecture is loosely coupled. Eventually, the developers create this function to be more effective and more efficient at the same time, and it can be more modular as well. And also, because of loosely coupling, refactoring of all the codes will be much better and more organized at the same time. I truly think that SOA is quite suitable when building a very, very big system where the services can be independent and can be joined easily. So, like I said, refactoring will be much easier. But at the same time, complexity is a challenge to actually merge these services in a system, because, like I said, services can actually return millions of messages and to exchange data. So the complexity is really, really high when actually to implement a big system using SOA.